So now I'd like to hand over to Mr. Professor Kotake, who's today's moderator. Professor Kotake.
Okay, thank you very much, Ms. Shibaike. And so welcome to this third webinar. My name is Naohiko Kotake from Keio University. I'm one of the steering committee member of Multi-GNSS Asia, and I'm happy to join this webinar today. And so she already mentioned that we have 5 presenters, including me, and so they will try to presentation related to the smart city. And so the subtitle is Data Driving Smarter Decisions. And I hope you can get several insights from their presentations. And so today we have a various kind of presenter from Thailand and Australia and Japan. And so I think the participant also from the various countries. And so we can discuss the after presentation. So please describe your question and comment on the chat. And so I will pick up several comments to the speakers. And so the first session is what's a new recent trend and applications, and 3 presenters. And first presenter is Dr. Natalie Watt, and so from the Chulalongkorn University. And so the Nat-san is one of the partner from Chulalongkorn University. And so please have a presentation about your activities.
Okay, thank you so much, Kotake Sensei, and hello everyone. Okay, I'm very happy that I have the opportunity to share you about the topic related to the recent trends and application. And I want to share you one application that we did. It's about SNS, social networking services, and using GNSS to do something in order to come out with the output of the smart and sustainable tourism business. Okay. First of all, I'm Natalie Watt from Chulalongkorn University. Actually, my background is industrial engineering, and I'm also working on the data analysis, disaster and risk management. I work with many counterparts in Japan and other ASEAN countries as well. And because today assignments that I will be the first presenter of today, so I hope that you enjoy my talk. And because the talk has to be something about the current trend and application, that's why I want to pick one of the current project that I'm doing, and I think it will be interesting for you. It's a project that we from Chulalongkorn University work together with the graduate school of SDM from Keio University in Japan. I think the expertise from our side is social networking analysis, like the Twitter analysis, machine learning, and also artificial intelligence can collaborate with the skill and expertise from Keio, which is about GNSS and GIS analysis. And by having this, we also receive the supported from the JICA ASEAN University Network, or AUNCNet, with the program called the Special Program for Research Against COVID-19, or SPARK project. We proposed and we got accepted for our project for COVID-19 data analysis using the mobile services data and the satellite geospatial data to sustainable tourist business. You may wonder what it is. Yes, we have to say that in Thailand and in Japan, right, tourism business is one of the major income of the countries. And due to the lower and decreasing of the traveling fee, comparing with the last decade, I think many people want to travel overseas and go to discover somewhere that they have no experience before. However, after the COVID-19 situation, as you know, that this business have to going down. All the business like the restaurant, hotels, service providers, they cannot keep continue like what they did before. And this is the reason why we want to go on. We focus on both Japan and Thailand. These countries, we pick some of the tourist spots in Japan, like Tokyo, Osaka, Hokkaido, and others. In Thailand, we also pick some famous cities like Bangkok, Chiang Mai, Phuket, in order to be some study case. And we use the data from the satellite because, as you know, actually now we have many open source and many open data that are available for us to analyze and do some things. We combine it with the Twitter analysis data from those countries as well in order to generate something. But the difficulty is not about how to get the data because it's available for open access online. But the difficulties is what is the algorithm that we can use them to do some things. That is the reason why we have to combine our equities together from both Chulalongkorn University and Keio University sides. And the goal and point that we want to go on, we want to use this data to indicate some unusual situation in those tourist hotspots. We want to learn the people attitude and intention, both the domestic traveler and the overseas traveler, what will they do? Then we can provide some guideline and recommendation to the government and the tourist agency in order to enhance the sustainable tourism business. So I don't have much time, but I just want to pick some technical algorithm that we use. For example, we use the co-occurrence analysis for Twitter tweets that we already published. You want to learn more, you just check it from this QR code. You can download the paper to read all the details. This one we can catch up what is the current trend and what is the connection between each tweet and each word that normally people are posting in their daily life. We also use the Twitter sentiment analysis. This technique is the part that we want to learn. People feel positive, negative, or feel neutral with the tourist perspective in some area. We published our first paper for Bangkok tourism, and we are going to publish other papers in other area later on. And lastly, we also published a paper by using the GNSS data to analyze the chain of some gas. We pick the nitrogen dioxide gas because it can monitor some human behavior or human activities. And we try to match this chain of the nitrogen dioxide together with the activity related to COVID-19 response from the government in one province in Thailand. And we also found that they have some significant relationship as well. So I think what I want to convey to you is that we can find out and collaborate the multidisciplinary knowledge and discipline. Not only one way, but you can combine tools or three expertise, then you can come up with something that it can produce impact, not only for that field, but we also can produce to other variety field. I think these examples is one of the achievements that our team received because we also won the Best Paper Award from the IEEE ICA Symposium Conference due to our contribution and the impact of this research. Not just learning what data tell, but we also can create some contribution of those data analysis to policy or to the implementation in the future. Okay, I think the message, the last message from my short talk is that try to think of what you have and try to catch something that you don't have, but maybe your friends know and your friend have those skills. Then you combine together, you can create the synergy, and that one can make your plan or your proposal success. Thank you.
Yeah, thank you very much. Very good presentation. But I think this is a very limited time. And yeah, thank you very much. And so the second presenter is Dr. Akira Kodaka from Keio University. So please turn on the microphone. Oh,
Okay,
relax.
So yeah, I'm muted. Thank you very much, Kotake Sensei. So my name is Akira from the Keio University. Technically, I'm working under the Professor Kotake at the Grad School of System Design and Management. And I'd like to talk about smart city and especially disaster risk reduction. And we are saying like tailor-made disaster responses based on like people who we want to help like where and who and when. Like this is like tailor-made disaster risk reduction and the countermeasures based on location based data. Okay. So the target issue here, as we know that our society is now getting very much complicated as well. So this is an example of the photo. So it's a platform of the train station, and maybe like rush hour in the morning commuting time, it's congested with the people, but at the same place, but maybe during afternoon, like 1 or 2 p.m., there are not much people. The thing is, even we're seeing the same place, but the dynamic or people who are very much different, along with the time and as well as the season. So the point is disaster risk is very much complicated and much of like dynamic. And the gap is the static response. Now we have, especially in Tokyo, that I'm going to talk about a little bit in detail. They have like very, very limited data and decision-making material. So the response of their responses are very much static. So we are trying to fill this gap to make static government responses, to make it as a dynamic, to tailor-made about the actual situation in the city dynamics. And also we are working together with the project, also Dr. Nat as well. So I think this video will be shared later. So maybe detailed information you can refer to the URL written in the below. But the big umbrella, we're working together under the Belmont Forum and collaborative research action, and especially the Japan and Taiwan, and also we have a USA team. So we're collaborating with the university and the local governments and stakeholders to fill the gap that I mentioned previous slide. And this is an area of interest. USA, the Penn Station, Grand Central Station, and Tokyo here, Tokyo Station, and Taiwan's Taipei Station. So I'd like to go a little bit details in the area around the Tokyo Station, which is we call a little long, Marunouchi, Otemachi, and Yurakucho area. So this area is known as one of the largest districts. It's around the Tokyo Station and has about 120 hectares. And the thing is, it's 13 stations there on 28 lines. And also it's creating like 10% of entire sales in Japan. So it's like a business district as well as a tourist place as well. And this area is designated as one of the prototype area of the Tokyo City, Smart Tokyo Leading Area. The keywords are API, Society 5.0, Digital Twin, City OS, these things. So the government and local entities related to disaster risk reduction is trying to get it as like real-time decision-making by using the data that are available from this area and other area as well, using also open data. So this is what we are doing. So the first of all, we are using the data source as the mobile phones. We're collaborating with the Yahoo Japan. So we're also using the location data, and the people are like searching quietly what kind of keywords that they are searching. And this is, and also SNS tweets, as Ajahn mentioned. And also some open data of the weathers and person trip data and these things. So, and then we're trying to put it in as a population density distribution map and the 2D maps like this. And also focusing on a specific point, and we draw like a histogram. So which time the people are more in there and when the density gets lower. So for example, about in the morning times, about 7-ish, people are more using this area. And then later on about 6, when the people going back to the home, maybe the station gets clouded again. So this dynamicity we draw using the data available. And then we make it as a model, so like a pattern. So there's various and thousands of patterns, but we need to focus on something very serious patterns or very major patterns out of this people flow analysis. And then overlapped with a hazard scenario, for example, a fire or flood or earthquake, and overlay with the city dynamics and the hazard map. Then we can create something about the simulation of the hazard or a risk scenario. So based on this risk scenario, we can provide or propose to the government or who are responsible in the disaster risk reduction. So by using data-driven analysis, we are proposing something like the dynamic disaster response. So this is our concept. And others are complementary open data source. So this is a general transit field specification developed by the Google. So we not only just the people flow, but also we can use public vehicle movement of flow. And once this is Manhattan area, and once we make it as a heat map, so we can see like during 8 and 9 a.m. in the Manhattan area, which part that the buses are congested. So like this spatial distribution, also we can use it to understand dynamicity of the risks. And this is a further advanced, but not that far challenges that also not just only the people flow, but also depend on the area and what kind of keywords that they are searching. And then by like text mining technologies or the big data analysis, then we can kind of extract the disaster needs out of this, the people searching behaviors. And also to knowing about their demographic data or like the behavior patterns of how to use a mobile phone. Then based on this demographic data, we can kind of categorize it as to tailor-made what kind of information that this person would know. For example, if we can know about the people who have routine diagnosis with a doctor, then once disaster happens, maybe you can provide something about the medical supports to this person, like this kind of real-time decision-making. We are hoping to help out of this, our project. Okay, so this is it. Thank you very much for your time.
Yeah, thank you very much. Very interesting presentations. And so please send some question or comment on the chat. Okay, and the final presenter in this session is the Mr. Peter Knight from Australian Trade and Investment Commission in Japan. Yeah, please.
Thank you very much. If the secretary could put the slides up. Thank you. If you could move to the first slide. Thank you. So I'd like to talk about two things from an Australian perspective. The first is how we're building in satellite data and imagery into smart city development. And the second is around how to build resilience in those systems, and in particular, in regards to disaster and emergency signaling systems, some of the tests that we've been conducting very recently, along with Japan, on the QZSS emergency warning system and how it could be applied in Australia. But if I can first talk about the smart infrastructure strategy that's been applied for the development of Sydney. One of the largest smart city precinct developments in Australia, and possibly even the world, is in the Western Parkland city of the Sydney area. Essentially, that is a city about the size of Dallas that's being planned to build out over the next 2 decades, with about over 1.5 million new households being created, a new airtropolis area with Western Sydney Airport being the catalyst for that growth. So there is some major infrastructure development that's being planned for that. And to assist in the planning, we've been rolling out a series of initiatives in how to use digital twin modeling to assist in the planning and development process. This is being captured in a number of policy releases that are being done in New South Wales, with the infrastructure data management framework being released last year, along with a spatial collaboration portal, which was launched in February 2020. These are being coordinated with the federal government and in particular the Geoscience Australia and the Commonwealth Scientific and Industrial Research Organizations, Data 61, which focuses on its spatial services, have been key partners to the state government in developing this platform. The New South Wales Digital Twin, which I mentioned was released in February 2020, will focus on creating models for the planning and then delivery in the Western Sydney area. And those models will be built incorporating both remote sensing data from satellite services, as well as incorporating IoT sensory networks into the infrastructure itself. In order to assist with this, the government has developed a series of policy and guidelines for how that infrastructure should be incorporated. If you can go to the next slide, please. This is a model of how we see that system working. So as you can see at the base level of data input, remote sensing data will be a core component of that. That will then be aggregated up, and we're creating a governance system for the standardization of data that will be incorporated into building information models. And this will support the development of those models within digital twins. The vision that we have is that there will be smart delivery, where an infrastructure company, when it completes a major project, such as a bridge or a road, will not only deliver that physical infrastructure to the government, but will also deliver a digital twin of that infrastructure that will be able to operate in real time and be updated as the infrastructure is being used to optimize the use of that asset and to ensure that things like predictive maintenance can be done on those infrastructure for smart cities. If you can move to the next slide, please. Just to emphasize, for us, smart cities are not just about the city itself, but about the infrastructure that is being built out using the same kind of smart grid platforms and regional data. As you can see here, we have a plan to develop these hubs throughout the state of New South Wales. One of the key issues there is the vulnerability of this infrastructure to bushfires in particular. As everyone probably knows, we suffered from major bushfires throughout Australia, and particularly in New South Wales. In order to try and strengthen this system, which at the moment relies on a terrestrial-based telephony emergency warning system, we are looking to collaborate with the Japanese government to have satellite-based emergency warning systems. The Japanese QZSS system has a very robust platform, and in August last year, New South Wales Rural Fire Services conducted a test of that system by uploading a message through the NSPS to be broadcast by QZSS. We successfully received those emergency signals, and we would see this as a first trial. We are looking later this year to a report that will recommend how we can upgrade the national emergency warning system for Australia. We would look to do that in a way that is compatible with international standards. And we think there's a great opportunity to work with the Japanese governments and with other countries in the region to roll out satellite-based emergency warning systems. So we're very keen to collaborate when it comes to both the incorporation of satellite data into our smart city development, as well as into our emergency warning systems and preparation. We'd be delighted to answer any questions about how we're looking to do that in the end of this session. Thank you.
Yeah, thank you very much. And so, yeah, this is an actual real project in Australia. So I'm interested in this early warning system. Okay, so let's move to the next session. Next session is what's the technology behind lessons learned from MG experts. And so the two presenters, and one presenter is Dr. Damrongit Niamanuad and me. And so the first, I will have a presentation. And so the next is Dr. Damrongit. Okay. Oh, hello, Dr. Damrongit. Yeah, I will have a presentation before you, and after that, so please have a presentation. Okay. Okay, and so I will show several examples related to the GNSS applications. And first one is agricultures, and so so this is an actual research project, and also currently the company is using this technology for their process improvement. And so our target field is the very big field plantations. And so one of the problem is the precise positioning for the replanting. And so the currently problem in the conventional replanting method is low efficiency and low productivity. And so the company asked us to improve this point. And so yeah, this is our study, and left side is the previous processes. So they use the manual-based land survey. And so the country, we are applying the RTK Multi-GNSS for the precise positioning. So we can apply the GNSS technologies. And so this is the prototyping. And so you can see some small sound. So in this system, so this system tried to use a Multi-GNSS RTK, and so we use a various kind of GNSS satellite. And then the outside, so that sometimes it's difficult to see the display. Then, so we use not only display, but also sounds. And the worker can realize the precise target point with the sound and the visuals. So then this is a prototype, but the most important point is the usability and the user experience, because this system is a little bit complicated technical system. And so we have a many trial and discussion with the workers and users. So this discussion and observation is very important. And then, so finally, we discussed that we make an image of the new smart shoes for the precise positioning. This is a very fun and enjoyable and very small, smart looks. And so currently we can use 3D printers and many, how can I say, prototyping tools. Then, so this is a system architectures. And so that we try to make this kind of system with 3D printers. And so we can realize in 1 month. So this quick prototyping is very important for realize new technologies. Then, so this is a prototype. And so the worker, you can see the smile looks. And so this, how can I say, the feeling is very important. Not only technical the aspect, but also how can I say, the feeling is very important to create and start the new services. Sports case, and so we are trying to use a GNSS system for the various kind of outdoor sports, because the people are using the Multi-GNSS devices on the back. So this is a current trend. And so with the Multi-GNSS technology, we can realize precise positioning. So we can compare the positioning, the GNSS and a Multi-GNSS. And yellow one is a positioning with Multi-GNSS. In this case, we use US GPS, China Beidou, and Japan QZSS. And you can see that this is a very, very precise. And so we can use this system on the actual outdoor sports like this. And so the left side is the data from Multi-GNSS, and the right side is a visual feedback on the camera. And so only with the GNSS data, we can analyze the many performance of the athlete. And sorry for Japanese, but you can understand the total distance and the speed. And also we can apply some physical sensors, and then we can estimate their injuries. And so the benefit of this kind of technology is prevention of injuries, and we can communicate with the various stakeholders with this technical data. And so that, as you may know, the multi-GNSS, we can receive this signal all over the world. And so we can expand these lessons learned from Japan to the outside the countries. And so we can supporting the Asian countries. So this is a national team of Indonesia. And one of the point is the cost down and high reliability. And so that now we have a small ventures. And so the country also we realize the cost down. So this sports device is less than $100. So this is a very cheap for the sports people. Yeah, so this is a very, very new system. And we use the U-Blocks receivers. And also the combination with technological data and visual data is very important. And so we are developing a new sports analytics tool with the Fujitsu company, Japanese IT company. So this is a new system and a cloud-based, and any team, and high school team and a university team also using this system. And finally, livestock. And so that we have various kind of experience with athletes and workers, and this means the humans. But we can apply this system on the animal, like the cow, because the condition management is very important in livestock. And so we are applying the multi-GNSS devices, all the animals like this. And so we can manage the condition. And so sometimes we can support these animals with this data. And this condition is very important. And so, yeah, I want to say that technology is very important, but the service user is interested in not only technical originality and uniqueness, but also the service value. Then, so the usability and the communication and the user interface and also business model is very important. So this is a key comment to the audience. Thank you very much. Okay, and so the final presenter is the Dr. Damrongit from Jista, Thailand. So may I ask have a presentation, Damrongit?
Yeah, thank you for your introduction.
Yeah, thank you.
You see my screen, right?
Yes, yeah. Yes.
Okay, so my topic is smart city in the post-COVID era. My name is Damrit Niemot, the Acting Deputy Executive Director of Jista, Thailand. My topic is quite big, but I will make it in short. As you may know, COVID-19 crisis and smart city seems to be go along together in this period of time. You can see that the impact of COVID-19 make some experience of isolation and lack of connectedness between cities and also countries. As you may know, there are a lot of definitions in terms of smart cities. And before, many people believe that, a lot of people believe that the smart city is something nice to have. But in this period, COVID-19 pandemic, we believe in, especially in Thailand, we believe in the resilience to the situation, and the integration of physical and digital environment is something that we need to cope, and the solution is needed for this kind of situations. You can see from the screen, a lot of technologies drive smart cities, and we have to think about the new way of making connections between people in this in this situation is something very difficult. Especially in Thailand at national level, we are trying to use the technologies for the solution of trying to monitor and managing many things for the situation. On the top right, we use the system for managing the lockdown, ensuring the connectivities, and also this connectivity represents something for the economic stability also. We cannot lock all the system, I mean the human activities and ignore all the activities of humans. And also the system is that we are looking for in Thailand is to manage the reopening and compensation. Also, we trying to use the system to setting up the health facilities. This is something that we make it in Thailand. We prepare all the things if the situation is bigger than we think. But on the base on the how I say the ground and the information that we need is not only the geoinformatics. It's something we call citizen applications and government data combining together for the analytics. What I'm trying to say is TISDA create something called IMAP for the prevention and mitigation on the pandemics at the national level. And as I mentioned, we have the government issue many citizen applications, and all the data of the government pull together, integrate in the system to manage and mitigate all the event. This is what we're trying to do at the national level, and we're trying to scope down to the city level. You can see the number on the screen is what we have, like the health facilities. And in Thailand, we have the announcement every day by the Center of COVID-19 Situation Administration, and the government used the system by TISDA to show to the public the situations and how the government mitigate all the events. And right now, TISDA trying to scope down to the city level to manage at the city level and trying to reopen in national level. What I'm trying to say is the post-COVID era is something that the smart city will be transformed to. The example in Thailand is the Phuket city. The Phuket city expressed their willingness for the smart city to be in 3 key areas: epidemic disease, crimes, and environmental threats. And this is also the opportunities for our community to share our experience to what the smart city will be show in the near future. And also, I would like to almost my last slide. I show the analysis of the talent gap of digital skill in Thailand. You can see from this slide that a lot of the gap in Thailand in data analytics, software application developer, and analysis. This is the way that we believe that is opening up for collaboration with partners, not in the far away future, but I think right now the pandemic accelerate all the activities of analytics and smart city and transform the smart city in the way that the people think that is something we need to do it right now. In conclusion, I believe that smart city in post-COVID era is the opportunity for us to direct and steer transformation focus for all the smart cities. This kind of situation is an opportunity to improve and share digital connectivity between government agencies, business sector, and citizen data. This is the case of Thailand, that government agencies, to get into the government agency and citizen data is not that easy, but this pandemic situation, we can get all the data pooling together, and we can work all the data with their willingness. We also learn a lot of human experience with a lot of new applications from the government. We have many applications from the government for the pandemic situation. And what we learn is how the Thai people get into all that applications also. And the last thing that I think is something that our community can respond to is the collaboration for solutions that we can show and demonstrate to the smart cities, and the goal of with the goal of recovery and economic sustainability in the very near future. I think this is something that the smart city need to be, and our community can respond to. Thank you.
Yeah, thank you very much, Dr. Damrongit. Yeah, I understand the situation in Thailand. Okay, thank you very much for 5 presenters again. And so that now we will move to the open discussion with Q&A. And so I will moderate these discussions in about 10 minutes. And so now I have several questions from the participants. And first question is to Dr. Kodaka. And how much does location affect the response system? So may I ask to have comments?
Thank you very much. How much does location affects the response system? So my understanding towards this question is how the location information contributes to strengthen the disaster response system. I'm not sure I'm understanding correctly about the questions. Yeah, but location itself, what I wanted to share with you today is a location. For example, when we talk about it just only in Tokyo area, but the people's density, so it's not just only one, but like the crowd of the people flow. And when we map it, then during the morning time, maybe the people are more inside of the Tokyo station and surrounding area. So once disaster happens, maybe people will be confined within the Tokyo station area. So the government will think about it once disaster happens in this period of time, what kind of preparation that they need beforehand, or what kind of agreement that they have to make it within or among the stakeholders. So location is like risks also can be changed along with the location. Also somewhere in Tokyo, also they have a wooden-based buildings are there. So their fire risks are high. And if the people are there at some point, and then when we think about a disaster scenario at a period of time, when the people are getting together around the vulnerable buildings, then people may think about the firefighters should be going to place, not taking a long time. So this is kind of location-based scenario that we create and then think about the disaster preparation along with the dynamic or city dynamics of the real world. I hope I answered that question.
Yeah, thank you very much.
Okay.
And so there are 2 more questions, and the 2 question is to me. And so the first question is GNSS and the cow is very interesting connection. And what is the relation between condition management of cow and GNSS data? I want to know in more detail. Okay, thank you very much. And so this session is very related to the GNSS application for the athlete, rugby players, because the cow is on the field and a very big field. But the cow manager cannot check the condition of the cow because sometimes the cow is far away. And so on the GNSS receiver and the condition sensors, so they can get their data via network, and anytime, so the manager can realize their condition with GNSS data and condition data. Then sometimes if they have some the irregular trend of the data, and so the cow manager contact to the target cow, then so they can prevent injuries and they can support the cow. So health care is one of the application with GNSS. And so additionally, and in our case, we are monitoring the condition on the ground, grass, with the remote sensing data. With the remote sensing data, so that we can understand the condition of the grasses. So cow is eating the grass, and so we can control the cow and on the ground field. So this is a very smart agricultures. And second, with regards to the GPS, can we apply also the plants on what commodities are available in this area? Okay. So now the GNSS technology is becoming a much more commodity and high reliability. And so there are many GNSS receiver and tools for the agriculture and outside. So you can search the Google, and so you can buy some GNSS devices. And if you cannot find the GNSS devices, so please contact to the Japanese Cabinet Office, and also us, we are GNSS expert. And so the very cheap receivers, it takes about, how can I say, いくらぐらいですかね、0.5 or 0.3, about 30 US dollars about, and it's not expensive. Okay, so you can try this system. And any other question or comments? Oh, one more, okay. This is okay. Maybe, okay. Yeah, new comments and the question. Thank you very much. And okay, so does a post-COVID smart city application in Thailand already have more specific features such as citizen profiling? What data can be accessed by the public, automating some government processes? Maybe this is a question to the Dr. Damrongit and Dr. Nat Liwat. May I ask to the Dr. Damrongit?
I think some data can be accessed by the public. I think the most difficult things for I mean, how can I say, the data to be accessed is the private data. The government agencies get into the data, that kind of how I say, private data because of this spatial situation. And we cannot show all the personal private data to the public. We show to the public with all the analyzed things to the public. I think in Thailand, this is something, the issue that we have to learn and adapt in the future, the things that we have to discuss about private data, I mean, personal private data. And I think it's something that I think like in Thailand before, we cannot even think about these kind of things, but this kind of the COVID situation, we can get the data and we can analyze. And I think in the near future, we have to talk about this. And I think in many countries also.
Yeah, okay, thank you very much. And so, yeah, I want to have same question to the Peter Knight because that he knows the Australian case. But before that, I want to ask several comments from Dr. Nat Reward. Do you have any additional comments about this question?
Yeah, I agree with Dr. Damlongwit that due to the less experience in Thailand, that we did not have much experience in terms of pandemics comparing with other countries. And in terms of less awareness, I can say that we did not have much awareness like in Japan in terms of the privacy and personal information. That's why lately the government also issued some of the new acts that link to those privacies. And similar to what Dr. Damluk already mentioned, that yeah, the data for all the consumer data and personal data will not be provided to the public. But what we can see is mostly already analyzed data. When we go back to see some other country previous published paper like from Japan, from Singapore and other country, yes, they also recommend that all this data should be highly collected with only the authorized people that can be seen, because after the pandemic passed, if this data still available, it can show somehow the information leak to the societies.
Okay, thank you very much. And so the Mr. Peter Knight, may I have a question about the same? What data can be accessed by public automating some government processes?
So actually, in the applications that we were talking about with digital twins for design, the data access challenge is slightly different. Most of the visualization of infrastructure is available to the public, but where it's dealing with sensitive infrastructure, such as where particular pipes run or where cables go, where telecommunications infrastructure is, access to that is staged. So depending on your level of participation in the digital twin, if you are a contractor who needs to know where that infrastructure is in order to build and carry out construction, then you are given different access rights. For the general public, though, there's an ability to be able to see the visualization of that digital twin data and be able to kind of sort of do fly-throughs with the models. In regards to other data that would be gathered, not necessarily from remote sensing, but potentially from IoT, similarly, we would have sort of levels of access to that. So for things like crowd data, looking at the flow through of traffic in stations and that kind of data, where it is anonymous, it would be public, or where it is personal, then it would be kept private. And actually, a lot of the government policies relate to ensuring good cybersecurity practices to ensure that infrastructure data is kept anonymous.
Yeah, thank you very much. Very detailed comments. Okay, and so any other question or comment? Okay, no questions from the audience. And I have one question to the Dr. Nat Reward, to the other presenters. May I ask some comments? Nato-san?
Yes, sure. Yeah, I think what we learned today is that yeah, from variety of field we can learn the application and the existing platform technology that have been developed. So I have not kind of comment, but like some question in terms of technical terms, no, technical specification, that the current situation of the GNSS is still related to the satellite signaling and connectivities, right? Therefore, I want to ask all of you that is it possible that we can use GNSS for something that is like underground or indoor areas for the current technology that we have?
Okay. Any comments from the other presenters? Indoor positioning? Yeah, I have some comments. And so the currently, as you may know, the satellite signal cannot be received indoor. And so, yeah, we can receive the signal, but the multipass and the other, how can I say, the noise is also include signals. Then it is very difficult to the satellite positioning in indoor. However, we have existing other technologies like wireless network and Bluetooth. And so the current technology, we can combine the satellite signal and other signals, and the combination is very important for the seamless positioning indoor and outdoors. Okay.
Okay, thank you.
Any other comments? Okay, yeah, thank you very much. And yeah, thank you very much for the presenters, and thank you very much for the very good questions from the audience. And currently, the 50 participant is joining this webinars, and yeah, this is a very good numbers, I think. Okay, and thank you very much. And right now, the almost 7 p.m. and I will move to this discussion to the coordinators. Again, yeah, thank you very much presentations. Thank you.
Thank you very much.
Thank you.
Thank you, all our special guests, for your great presentation. Okay, now I'd like everyone to announce some upcoming events. I introduce you S-Booster. S-Booster is a space-based business idea contest hosted by the Cabinet Office of Japan. Additional value of this contest is the support to finalists by providing monitoring program to brush up their business ideas. Applications open to Asia and Oceania region. At the final round, presentations are held in front of inventors, large companies, and etc. to promote business matching. If your idea wins grand prize, you would get 10 million yen. Okay, let's see a promotion video about S-Booster for 1 minute.
Put the most advanced space technology into your hands. Apply satellite data. We can help realize your dream. You can polish your business ideas together with experts who will provide the strong backup you need for success. S-Booster is hosted by the Cabinet Office of Japan with the support of JAXA and others. Startups from Japan, Asia, and Oceania compete against each other. You can be the next winner. Space is no longer far away. Draw closer to and pioneer a new business area.
宇宙と今まであまり接点がなかった分野の方々がどんどんと宇宙産業に入ってきてほしいですね。
S-Booster will accelerate the realization of your dream.
Okay, so for additional information, you can also see detailed promotion video on the website. Okay, now I'd like to explain about the program a little bit. Application theme has 2 items. The first is business idea for utilizing space asset in collaboration with Japan. Example are collaboration with Japanese companies or utilization of Japanese space assets. Another theme is business idea for theme by sponsors. Entry about the schedule. Entry of business idea is scheduled in this spring. The qualifying is conducted in Japan and Asia round, respectively. The final round will be held in December. Method to participate will be online for some contestants because of the COVID-19. You can get detailed information on the website, which is announced in late March. Sorry. So that's all about S-Booster. You can check this website for more detailed information.